Streaming. Streaming takes place when video or audio files are sent to a receiving device for viewing or listening without downloading any file. In video streaming, the first few seconds consisting of several frames will be sent to fill a buffer, a temporary area of storage, which can then be watched at the receiving device. As frames are viewed, they are removed from the buffer and new frames are added. A buffer helps keep a video stream run smoothly. Without a buffer, any data congestion would cause the video to pause, miss out frames, or pixelate. The buffer delays the stream for a few seconds, so that the stream won't be interrupted if frames aren't arriving quickly enough. Data congestion can be caused by devices using up too much bandwidth both at the sending end and the receiving end. Switching. Circuit switching. This method of data communication creates a physical network path from the sender to the receiver before any data is transferred. All of the data is then transmitted using this single path. While the path is open, not her devices can use it. Once transmission is complete, the path is released for other data transmissions. This was used in old telephone networks. Packet switching. This splits data into individual packets before forwarding them to its destination. Individual packets can take different routes to the destination. The receiving end will then order the packets to reassemble the data. This way, each packet takes the most optimized route, and if packets are dropped along the way, the sending device will only need to resend the lost packets, rather than starting the transmission all over again. Message switching. This transmits the whole set of data together from source to destination. The data is sent to one network node at a time before being forwarded to the next. However, this is quite slow, since each node needs to process and store the data before forwarding it. This makes it unsuitable for streaming real-time games or real-time communication.